Welcome to the Walton Pi. Today I'm going to go through this problem from Abstract Algebra that has to do with R modules. Okay, so let's suppose that R is commutative, and let's let I and j both be ideals of R. For the first part of this problem, we are going to show that there is a surjective R module homomorphism from I tensored with j over R to the product ideal ij, which maps I tensored with j to the element ij. Okay. So for this one, what we're going to do is we're going to start by defining a function. So define, and the way we're going to define this is phi of the sum from k equals 1 to n of ik tensored with jk is equal to the sum from k equals 1 to n of ik jk. So this is a map. So phi is defined from I tensored j to ij. Alright, so there we go. We have our function, and so now we just have to prove that this is a surjective R module homomorphism. So first one, this clearly preserves addition. We defined it in terms of a sum, so this is clearly going to be preserving addition. The next one is we need to show that it works with multiplying by something in R is going to work. And this is going to suffice for a simple tensor. So what we're going to do is look at phi of R times I tensored with j. Well, this is equal to, let's see, we got phi of Ri tensored with j. Ri is inside the ideal I, so this is equal to Rij, which is R times Ij, which is equal to R times phi of I tensored with j. So this is going to be a homomorphism. So phi is a homomorphism. Next, we're going to need to show that this is surjective. So for any sum from I equals, nope, not I, any k equals 1 to n of ik jk in ij, clearly we have the element that we take phi of the sum k equals 1 to n of ik tensored with jk is equal to the sum that we wanted. So we are definitely going to have this be surjective. So all of that together shows that there is a surjective R module homomorphism from I tensored with j over R to the product ideal ij, which maps I tensor j to the element ij. Now let's try and show that this map does not need to be surjective. So let's let R be the integers adjoin x, and we're going to let I be equal to j be equal to the ideal generated by 2 and x. Okay? In this ideal, 2 tensor x is not equal to x tensor 2. I'm not going to go into the reasons why that's the case, but this is a true fact. So these two tensors are not the same, but if we look at phi of 2 tensor x, this is equal to 2x, which is equal to x times 2, which is equal to phi of x tensored with 2. So phi is not injective in this case. It might be in other cases, but in this case it's not. And so that is how we would go about and show all the work that we need for this particular problem. If this was helpful, please consider liking and subscribing, and please let me know what other types of problems you'd like me to do some videos on. I hope you have a great rest of your day, and good luck with all of your math.